Hello, everyone. In this segment of 10 answers to know about artificial intelligence information byte, we are going to look about 10 different questions and their answers. So here are the questions for us to get started. What is data? What do you mean by explosion of data? What is data science? What is data analytics? What is business intelligence? What are expert systems? What is machine learning? What is statistical machine learning? What is artificial intelligence? And what is deep learning? As you could see, all of these questions are something in very general in nature, and but they do have a significant understanding and significant they do have significance in order to understand artificial intelligence, and that is our objective of for this presentation. So let's look into very first one. So what is data? The digital representation of information is data as defined. In practice, I would say that a list of items in front of your table is data. The more information if you could gather by adding more and more column, or we say features, is data. And in general, if you look around yourself, everything what you really see can be digitized and represented as data. You look into an image, that is considered a data. Image has metadata in it, the external information such as the time image was taking, the location it was taking, the sensor it was taking, the resolution. Those are external information about the image. Then the internal information about image, that like what is in it. If that image is about a natural location, then you could say that you could see sky, you could see mountain, you could see water, you could see tree. If you want to extend that information, and you can say, is there a car, yes or no? Is there human, yes or no? So you can extend the metadata related information about that image as well. So just looking into one image, we can make lots and lots of information to represent digitally that information. Video is a collection of sequential images, uh, which is, significantly you can digitize, and you can make a digital presentation of it, which is already digitally, but in terms of data. Look into sound file, which is basically a wavelength frequency, and then depending on the audacity of information, page, and all those things, you can actually make that information as rich as possible. So we could finally say that data is a digital representation of any information which can be processed, analyzed, and can be worked on. The second question we have is, what do you mean by explosion of data? The explosion of data means the speed we are receiving the data, or we are collecting the data, is really very monumental. One example would be looking into the mobile technology. If you look into the your mobile device, it has variety of data. Its device itself has several sensors such as Bluetooth, Wi-Fi, radio, and if you look into the operating system, it generates so much data about how everything is really running, whether the operating system is stabilized or not, all different metrics related with all those things. That's a data. An average about 10 to 12 apps people use frequently, so those apps are generating data, usage patterns, how you are interacting, your behavior pattern, the way you are dealing, you are working with your mobile device, is that data. So there is lots and lots of data your mobile device is really sending. And if you think about the all those folks who have mobile smartphone in a city, how much data is really being created, and if you look into about a district or about a state, and finally about a country. So the countries like United States, where almost everybody has a smartphone, We look into India, China, where majority, a significant percent of population is having. So you could define, you can understand the explosion of data. If you look into our house, we do have IoT devices. We have devices which are Bluetooth and Wi-Fi enabled. They are generating data. Your TV, your set-top box, your Xbox, if you have those things, they all also generate data when they are running, when they are powered. So that is mean explosion of data. Not only we need to collect the data, we need to analyze, process, and get signaled out of it. So that is the meaning behind explosion of data. While we are talking about this topic, we also need to look into what is big data. So big data is defined as when you have really large amount of data, means large volume, and there is a variety in data as well as the speed the data is really being generated. So velocity, okay, velocity, volume, and variety. And when data is really coming in that way, our mobile technology example is one good example. If you look into healthcare devices, they almost everybody is really these days trying to wear a smartwatch, which again has lots of sensor and generating a lots of signals. So that's one example. So we could even talk a long term like about a variety of things we can think about. So that's the meaning of explosion of data. And when we talk about artificial intelligence, data is the key. And this explosion of data is big reason that artificial intelligence is has a very much significance in business world as well as in technology world. Our third question is, what is data science? When a science, a technology is driven by data, is considered as a data science. And it's very specific to domain, because if we talk about data, data is very domain specific. The data coming out from a mobile device is a very different data which is related with a finance or a banking application. Healthcare devices are sending data such as your vital statistics, your heart rate, your how many steps you are doing, where all those things related with your physical, versus IoT device which is running in, which is actually active in a manufacturing plant, is really generating the about how machines are running, what RPMs are, what pressure is, if there is, all those stats. So the data is very domain specific. So domain is specific science which is driven by data is what data science is. And the statistical and mathematical aspects are really used in order to process the data and generate results. So definition wise, data science is all about domain related data processed through various mathematical and statistical methods is considered as a data science. The real focus in data science is on data mining, how we are collecting the data, how we are cleaning the data, how we are processing, how we are making the data ready to process, how we are augmenting data with more information to make it more information rich, and then finally modeling it, understanding the data, extracting the information, and then modeling in a way that we can represent as a learning is part of data science. And that's all pretty much data science or data scientists really focus on. The cycle of data science is pretty much a 5 step. It starts with information capture. You have a variety of ways you collect the information and then you process it. You might need to understand and clean it, augment it, all those things you could have to do it. So that's part of your processing. Once data is processed and then it's ready to analyze, you could look at analysis is what generate the results. You generate the results, but again you are using in a business situation where somebody has to understand what is that. So you take that information and you communicate, you share with others, and this is a whole process. But the maintenance is the significant part of it, where you really need to keep making sure that this kind of system is really up and running. So these are the 5 aspects of data science life cycle. Our next question in this series is, what is data analytics? The analysis of data with an objective is data analytics. Again, data is very domain specific, so our objective will also be domain specific. If we have data related with healthcare, the objectives will be related with patient health, patient wellness, versus if the data is related with in manufacturing plant, then the objective related with the yield, downtime, prevention, predictive maintenance are related with that. So it's a very objective infused analysis of data is what data analytics is. And if we look into the what the act of data analytics is, and I would say the examination of the data to achieve what your objectives are, is basically the data analytics. And what you really do in data analytics, you process data, you analyze, you generate results, and you basically create conclusions from the information is given to you. Once conclusions are there, what happens is that there are some decisions and some of the results are made, and then you really need to follow them up by providing even more content. So analytics is basically providing a series of conclusions or information. They are backed up by a series of other information as well. So it's just like a chain of information which you can keep looking to and keep uh, browsing through each chain to understand, okay, this happened, then this happened, and that happened, that is because of this. So it's just like a lots and lots of information linked together to achieve the objective, what the reason you have started data analytics. Okay, so sometimes I would say that you can ask direct question or you can find the answer. You can say, if you have a data related with your manufacturing plant, you can say, hey, what was the yield last year? That could be analysis. You can also ask the question that, okay, how many times there was a downtime and how fast we could recover. That could be answered, looked upon in the data. Or say, what was the loss because of that downtime? That also can be answered over there. So analytics means the hidden information which is not directly available, but by analyzing you could collect that information, is data analytics. Reporting is also a feature of analytics, where you collect the conclusion or decision, some kind of information, and you represent them in very in a manner where a person who really didn't look into the data but has ability to understand the result. That's also part of data analytics. The next question we have: what is business intelligence? The business intelligence is a part of data analytics which is related to a business domain. So again, it's a technology driven process to work with data, to process the data using the technology. And what happens is that the key outcome from business intelligence is that the results what you really have, they are very I would say actionable intelligence. Means the intelligence is so good, which is trusted by the system, is that people can, or businesses can take action on it. They can depend on, because there is information backed up in a way with the results provided by a BI system, which businesses can bank on and can take action on, because they have a proof. There is a chain of information given which can make them, and which can make them believe that, okay, this is really very good thing, and we do have a full confidence where businesses can make, or people in charge can make those business decisions. So that business intelligence, once again, is a part of data analytics, which is very business domain driven. Okay, and again, a lots of technology, a computer technology, variety of methods are applied in business intelligence. Is a very big system, whereas the sales related business intelligence system would be very different than the healthcare BI, because of variety in data, as well as the domain is different, the outcomes are different, the questions are different, the actions which are taken on those results are very different. So that's what the BI really stands for. Now we will look into our next question. Our next question is, what is an expert system? So expert system is a part of artificial intelligence technology. I didn't put artificial intelligence at this point because my objective was to make you understand expert system first, then define artificial intelligence. That will help you to understand what these two things are. They are somehow related in some way, but they are very different. So expert system, or an expert system, is a computer program to simulate a certain environment completely. I would say that example would be that a robot which really working in an automobile industry, where they are really creating these cars, almost like a 70-80% of job is fully automated in companies like Toyota, Honda, and then the US companies like McDonald's and Ford, etc. So there are robots, they work in a particular location, they understand everything what needs to be done when the components are coming, how they really need to attach them, how they really need to weld them, or how they really need to screw them, bolt them, and in which angle, which direction, everything is really being taught about, and how to do it, in which order they will come, which order they will be connected. So if you look into all the knowledge are really given to them, and the rules are made for them, and the sequence are also given for them to follow. So an expert system is a very environment related system where a program is also there to make that whole system work, how to consume the knowledge and how the rules to be followed. So expert system, they are perfect, however they are limited for the environment. So they are not generalized, they are very specialized. There could be a system which can be created in a warehouse floor where the items are really being moved. So for example, in Amazon has big warehouse, their packets are thousands and thousands of packets are moved from location A to location B within the warehouse. These robots are fully trained, they know, they understand the dimension of factory floor, they understand which location they are, how many feet they can go left, how many feet they can go right. So they are trained in that way. So that could be another expert system. An expert system can also be created a bus which really moves between two terminals. The condition, road condition, all those things can be fed to this automobile, and rules can be created when this bus can go between these two terminals. So it's a very specialized system which fully perfect, but that cannot be duplicated to other environment, because the knowledge and rules, they are only specific to the environment where the expert system is designed. One example of understanding expert system is a digital receptionist. If you think about a receptionist, her job is to answer the folks are coming to that premise. It could be a business location, it could be just a a physical location where people are asking question, where it is, how to go, is the person is there, what's the number, can I drop this information to them, can I ask this question. And a digital receptionist can be trained as an expert system to answer all the question, what is about in that building, what is about that premise, and that person, a digital receptionist, can really answer. So expert system is a limited way to create some kind of artificial intelligence system, which is not artificial intelligence because cannot be it's not generalized, but it in one particular environment or the given environment, it's really very suitable and it's works fine. The next question we have, what is machine learning? So machine learning in definition is a part of computer science, and it provides ability to learn from given data without explicit programming. It means the algorithms or the technology used in machine learning is to learn the information from data without programming. It means it's a very generalized system where information is given. It could be variety of information, it's just information, and depending on the information is given, it can learn from it. Same algorithm, same technology can read the banking data with same efficiency as it can read the data coming out from a factory floor or manufacturing plant sensor. It's the same generalized way to understand, process the data, and then learn from it. So result of machine learning process is a machine learning model. And what is machine learning model? A machine learning model is basically a digital representation of the learning from the given data. If you are providing manufacturing related data, the model will have understanding about a manufacturing process, whether it's you are asking about a downtime or you are asking about the yield. Same thing if you are giving data related with healthcare, where data is available for predicting if a person is going to have a certain disease or not. That model will tell based on information given that is this person is going to have a certain disease or not. So very target oriented or target specific system which can learn from data and generate a learning model from it. But there is no need to program them like the way we are really trying to add rules and process the information such we were doing in expert system. So what is machine learning technology? The machine learning technology is a way to create the computer program which can automatically learn from data and create the model. So a machine learning is just a technology where you can give the data and then system can learn from it. It's okay, and then create an output or create a product which has everything what it really learned from, so which can make decisions going forward without the need of original data to understand. Such as in analytics, all the analytics or reporting is really done after processing all the data. Here we have the learning from the data which can act and can make decision when the new data is really being applied. However, the machine learning technology is a way where the computer programs can automatically learn from data and just generate the model. So these are two separate things. And what happens is that once the model is generated, it can be used to make decision. And one very simple example we can take about machine learning is a predicting house price. If you provide about 10,000 to 100,000 house records where you know what the house configuration is, which geographic location they are located, and how much they are really being sold, a machine learning system can learn everything from this information. And next time when somebody would like to sell their house, they say what would be the optimum price I should quote for, and then machine learning system will give them a number which can be used as a very predictive house price where the seller can sell and the potential buyer can buy the product. So that very good example of looking into machine learning, where the machine learning system learn from data. Very specific problem here to predict price, but it's a very general way. No need to program it, just data was given and the system use technology underneath technology to just learn it and generate the model so it can predict results. Our next question in this series is, what is statistical machine learning? In previous question we understood what is machine learning, and in this the statistical machine learning is a part of machine learning which is using the statistical methods. Statistical method means statistics, okay, and it just use variety of ways to applying these statistical methods, concepts to process the data and learn from it. It's not really very new. Over 50 plus years, even like 70 years, the industries such as finance, banking, and insurance heavily used statistical machine learning and statistical modeling techniques to work on data and build a machine learning model in it. They could actually, in some way, they can actually predict the inflation rate in coming years. They can also predict the insurance premium for a person, whether it's a life insurance or it's a commodity insurance, it's anything related with that. And I would say that lots of current businesses, even they are Fortune 500, they are heavily using statistical machine learning. So statistical machine learning is very powerful, extensively used, and it's very powerful. And the example we talked in previously, that predicting house price, definitely a statistical model can work very well on a problem like that, and they can be quite accurate. I wouldn't say 100%, but they will be very accurate to predict a house price which a person can sell and a potential buyer can buy. Okay, the next question we have is, what is artificial intelligence? Very good question. Almost everybody is talking about AI, ML everywhere. So I would say that uh, we can talk hours, we can talk very long discussion we can have about what is artificial intelligence. However, just to shake off understanding the concept behind it, we will keep it very short. In general, the artificial intelligence is a cumulative science which include variety of uh, knowledge, variety of I would say technology or educational point in it, such as computer science, biology, linguistics, engineering, mathematics, physics, and you can add a bunch of even other. It's a cumulative, it's everything. Computer vision comes in it, and then in information processing, image analysis, image processing, or everything can be combined together. Okay, so and then the gel here is a computer science, where the computer science and knowledge, all those things can be used to build these artificial intelligence system. So that's artificial intelligence. What is artificial intelligence, and why we really care about it? Why we are talking about artificial intelligence? So the reason is the objective behind artificial intelligence is to develop computers they can simulate or they can emulate a human activity. Means they can walk like humans, they can think like human, they can act like human, they can, they can even hear, they can see. So using variety of sensors you can, and then once you have sensors you can start collecting the data, and you can start processing the data. You can learn using machine learning methods, and then you can simulate the human like activity. So that's the objective behind artificial intelligence, is to making computers act like human, or pretty much become human. Not they replace human, but at least almost become human, so they can actually all the work which can be done by normal folks, which uh, can be replaced by computers. That's where we are really looking at artificial intelligence. In layman term, generally if something can be done in very short pulse of time, like a few seconds or second, can be replaced very easily by computers. Not a long term, it's going to take really some time before we arrive to that technology. However, if something can be done like a clicking a switch, processing bunch of sequence of operation, those things can be replaced by computers who can really simulate those behavior like human like precision. So it's umbrella technology covering various technology inside it. So it's not like one thing define artificial intelligence. The base behind is that let's make machines act like human. That's the objective behind it. How now, if we take this definition and look into, it's going to take several years, because the current infrastructure and technology and knowledge we have, making machines act like human is really very distant possibility. So what we could do in near term, so near term our initial goal is to at least make computers start working in some areas of human intelligence, such as they can learn and they can start solving problems, they can reason. So they can learn a game, and then they can play the game like the way humans are playing, and then those aspects can be used in real life scenario. So that's initial goal, and I would say that algorithms and infrastructure is really supporting where we can actually achieve great results in that area. The last question of the series is, what is deep learning? Almost everybody talk about deep learning, machine learning, and artificial intelligence. Essentially, deep learning is a part of machine learning, and the objective of deep learning is to develop technology which can act as close as human brain. It means the algorithms which are used in deep learnings are acting such as the human brain really learn. That's the closest way we can talk about deep learning. Means the evolution of data processing is similar to the way a human brain really understand. So deep learning is a technology, which which is a collection of various algorithms and an engine which can process large amount of data, and that's where the deep learning come. We can say that deep learning can also work on very small amount of data, doesn't require really very big engines to do it. However, the real results are coming when you really have a very good framework, or a good collection of processing power which you can feed your data into, and then depending on algorithms you are applying on it, you can generate learning out of it, and then the model will be much more effective to produce results. The core of deep learning is a neural network, and the neural networks are basically the algorithms which mimic human brain like functionality. We will be learning a little more about neural networks in other subsequent parts. However, in this to answer this question completely, we can understand the core of deep learning is a neural network, which are algorithms and which they act like the human brain act, and or the way human brain really learn or respond. Okay. Uh, in previous example we talk about predicting house price, and here we could say that we could actually use the neural networks or the deep learning to predict house price. The difference would be that the algorithms we are using, they are actually they are based on neural networks, versus the if we use a statistical machine learning, we are using the statistical model and the algorithms which are driven through statistical statistics aspect of math. So there is a difference. Math could be very different between these two methods of deep learning, whether it's a deep learning or a neural network or it's a statistical modeling. However, depending on variety of problems you are trying to tackle, in some case, deep learning would be the best answer. In other case, the statistical modeling will be best answers. In some case, one will outshine another. So I would say that this all depend on what your objective is and what you're really trying to do. And either deep learning or statistical machine learning or regular machine learning is really going to help you and you can achieve your objective. So these were the 10 questions. I will just put all those 10 questions in the screen, so you this is what we have covered in this section. And in other parts we will also look into other questions, and we will really deep into we will go fine we will have we will build an understanding about artificial intelligence in general. That's our objective. So once again, I appreciate your time. Thank you so much for it, and I will look forward to listening in my other lectures. Thank you.